Good morning, everyone. Any questions?
What'd you say? I couldn't hear you.
Any questions? Can you hear me?
Yes. All right. Thank you.
Okay. First, I said good morning, then any questions? All right. Okay, so we're going to keep working with, of course, 33 and 35. Okay, so I will look at those quickly. All right. So we have to find, okay, so I have 2 points. They are given to us in Cartesian, and we have to find them in polar coordinate, and they want us to find them in at least 2 different ways. So 33 and 35, which is the point -4 for square root of 3. Okay, very good. So let's start with the first one. 1 square root of 3. So as I said yesterday, the first thing I want you to do is sketch the point. So 1, this is my x, and this is the y. Those are the Cartesian, and you have to find the r and the theta. So this is a 1 right here, and square root of 3 is somewhere in here. So that's the point right there. Okay, and we have to find the theta. So immediately we see that theta is in the first quadrant. So that's the theta, and you have to find the r. So that's the simple possible scenario. R squared is x squared plus y squared, which is a 1, plus 3 is 4. So r, I'm going to take the positive r, so r is equal to 2, which represent that. So to find the theta, the easy thing is to use the tangent here, which is the y over the x. So if tangent theta is square root of 3, that's a simple angle. It means theta is pi over 3. Okay, so Cartesian copolar 2, so that's the r here. We have to be careful now. And the pi over 3, which is the theta. Okay. Now they want us to give more than one representation. So that's one representation. Who would like to give me another representation very quickly?
Wouldn't we just add, could we just add pi to pi over 3?
No, no.
Oh, no.
You add pi. You end
oh,
up
2 pi. Sorry.
Right. Yeah, you have to end up 2 pi. So we're going to end up 2 pi, which will give me 2 pi over 3 plus 2 pi, this is 7 pi over 6. I meant 7 pi over 3. All right, so that's another representation. Now, if somebody is giving me with a negative, another one with a negative 2, so Luke is giving me minus 7 pi over 3. Let's see if is he correct though?
Wouldn't it just be?
Sorry, minus 2 pi over 3. My apology. I did not copy it right. I was wondering. So it's minus 2 pi over 3. Okay, is this correct? Okay, let's see minus 2 pi over 3. What's minus 2 pi over 3? So that's pi over 3 minus 2 pi over 3. We go this way. And minus 2. So first I draw 2 pi over 3. So this is minus 2 pi over 3. It means this point here is 2 minus 2 pi over 3. So the point symmetric to, I mean, this reflection is absolutely 2 and pi over 3. So that's absolutely correct. Okay. And there are others. I mean, there are a lot of representation. These are just only two of them. Questions? Chris, you were saying something.
Yeah, just one thing real quick. So we use tan whenever it's in the first quadrant. We can use tan easily whenever it's in the first quadrant.
In first quadrant and in fourth.
All right.
Both would work. If you are in the third and in the in the second and in the third, you have to add the pi. Because the calculator will give you the angle in the first and the fourth. So you have to compensate for that.
All right.
So number 35, I think number 35 will address this issue. The point is -4 square root of 3. Again, first step, you have to draw the point because of the problem with the tangent. -4 will put me here. 4 square root of 3 will put me here. And this is the point. Okay. Immediately here, my theta is in the second quadrant. Immediately, the theta is in the second quadrant. So the r is easy. R squared is 16 plus 16 times 3, which is 48, which is going to give me 64. And my r is 8. So that's my r. This is the actual distance between the origin and my point. Now for theta, and that's really where the issue is. Now tangent theta is actually the y over the x. That's correct mathematically, which is minus the square root of 3. So tangent theta is this. The question is now when we find the tangent inverse. So if I find the tangent inverse of minus square root of 3, it means if I actually pick up my calculator and I find the tangent inverse, we are going to end up with minus the pi over 3 because the calculator will give me, it will not give me that angle. The calculator will give me that. This one. That's the minus pi over 3. The reason is this point right here and this point have the exact same tangent. So the tangent of this angle and the tangent of that angle are actually the same because they both the y over the x. So if we look very carefully, if I look at the x here, this is 4. If I take the symmetric one, and this is the -4 of square root of 3. So I take the y over the x, I get the minus square root of 3. So this angle here, this acute angle, and this obtuse angle, they have the same tangent. This is the one that the calculator will actually end up giving me because a calculator cannot give me everything. The tangent inverse is only the angle between minus pi over 2, pi over 2, not every possible angle. So we have now to be very careful. This is the minus pi over 3. So my theta is actually going to be the minus pi over 3. You have to add pi to it, which is going to give me 2 pi over 3. So my theta is going to be, so my point will be r. So this is 8 and 2 pi over 3. Now, if you forget that, as I said yesterday, it's really a trigonometry problem. It's nothing, it's not deep calculus. If you ever forget, that, we have to add pi, you can just use trigonometry. You can focus on this angle. Sometimes a good idea. You can take this angle, call it, I don't know, call it alpha, evaluate this angle on the side. So redraw the picture and work as if you have a regular right triangle. So if you do that, this is going to be a 4. It's going to be 4 square root of 3. And then you compute the tangent of alpha, which is square root of 3. Alpha will be the positive pi over 3, because if you are in a right triangle, you only work with positive. If alpha is 2 pi over 3, theta is going to be pi minus pi over 3, which is 2 pi over 3. So you can use, really honestly, trigonometry. You can use anything under the sun you want to find the theta. The only thing you have to be careful that the theta is from the x-axis till you hit the point. That's what the theta represents in polar coordinates. So this is my point, that's the r and that's the theta. And then we can start giving other representation. We can give representation with positive r by adding the pi to pi. That's one representation. And if I want a with a negative r, I basically need this point. So I can take this point is 8 minus pi over 3. So the one opposite to it is going to be minus 8 minus pi over 3. So that's another representation. And there are more. There are infinitely many representations. Okay, question before we move on. So today we're going to work with graphing. I'm going to pick up what I left yesterday in terms of graphing and then move forward a little bit. So sketch. So the first question is what we did yesterday. Sketch all point r theta that satisfy the following. Okay. This is something we started yesterday. So all the points that satisfy the condition are equal to 4. That means every point where the r is 4. So all the points that the r is 4, so there are a lot of them. It means all the point basically whose distance is to the origin is 4, because that's really what r is. So it's every point on the circle that is characterized by r equal to 4. Because when I say r equal to 4, it means theta could be anything you want. So theta could be pi over 3, pi over 2, 2 pi over 3, and so on and so forth. So this represents all the points where r is equal to 4. So this represents the equation of a circle centered at the origin and radius 4. So that's a circle centered at 0, 0, radius 4. So it's a very easy way to represent a circle. So in polar coordinate, we represent a circle like this, r equal to 4. Part 2 is, suppose I want to draw all the points such that theta equal pi over 3, where r is positive. And I will see in a second why I need r positive. So what does this mean? It means I want to sketch all the point r theta, where r could be anything. Could be 1, could be 2, could be 3, it doesn't matter. But theta has to be pi over 3. So I say, okay, and that means take it strictly, positive equal to 0. If r is 0, it's like this. If r is 1, I'm going to take the angle pi over 3. R is 1, it means this is the point. R is 2 is this point. R3 is this point. So it represents this line right there. The ray. It's not really a line, it's actually a ray because it stopped right there. So that's this ray. Now, suppose I remove the condition r positive and I give you theta equal pi over 3. What will be the change?
It would be a line, not a ray, huh?
Right, it's going to be a whole line because in this case, I'm allowing r to be negative. I'm not allowing r only to be positive. So the positive r will give me, so this is pi over 3. The positive r will give me everything on this line. But now when r is negative, it means when I start drawing the point minus 1 pi over 3, minus 1 pi over 3, this is 1 pi over 3. Minus pi over 3 is going to be right there. Minus 2 pi over 3 is going to be right there. So this is going to represent actually the whole line. So this line now become the line in polar coordinate. The equation of this line is theta equal pi over 3. So we can describe this line either as, you can find in the equation in the Cartesian coordinate, we need to find the equation of the form mx. So we have to find the slope. In polar coordinate, we describe this line by, this is the line given by theta equal pi over 3. Means every point on this line, its polar coordinate satisfy the condition, the theta is pi over 3. And the r could be anything. Now the other region, which is a simpler region, but this tell us why we use polar coordinate, for which region we use the polar coordinate the most. Suppose I ask you the following question. All the r theta such that r between 1 and 3, and theta, let us say, between pi over 3 and 2 pi over 3. Okay. So I want all the points that satisfy this condition. Who can describe those points for me? So all the points whose polar coordinate satisfy this condition. Means the r and theta satisfy both conditions. Okay, anybody would like to pitch in? In the distance from the origin to the point is between 1 and 3. The angle between pi over 3 and 2 pi over 3. What kind of region we're gonna get? If you want to describe all the points whose polar coordinate satisfy this condition. Anyone?
Is that going to be like an arc length with all of the points between it and the origin filled in?
Yeah, it's going to be like let us describe it. I mean, I think you're right, but it's not arc length. I don't know. It's the word arc length.
I don't know what the word for the
Yes, I
shape
know.
was.
Yeah,
I just.
Yeah, but otherwise, I think you're right. First, I want r between 1 and 3. It means all my points, I'm hiding the second piece. This is 1, and this is 3. It means all my point, there are, the distance is between 1 and 3. So if this is 1, and this is 3. So I know at least my point has to be between those two. In this ring, if you want. Okay, my point cannot be here, because if the point is here, the r is less than 1. The point cannot be here, because here the r is more than 3. So first, yeah, so first it has to be like, it should be within this ring between 1 and 3. Second, I want the theta between pi over 3 and 2 pi over 3. So if this is pi over 3, and this is 2 pi over 3. So I want the theta to be between pi over 3 and 2 pi over 3. So my point cannot be here, because if my point is here, the theta will not be between pi over 3 and 2 pi over 3. My point cannot be here, because the theta will not be between pi over 3. So the two conditions are satisfied right there, this circular region. This part of the ring. So it's the part of the ring where theta is between pi over 3 and 2 pi over 3. So those two inequality in polar coordinate describe this region right there. Okay, this piece of the ring, if you want, this region. Okay, and that's the best way to actually describe the circular region. It's easier to describe this region using those polar coordinates than Cartesian. Cartesian coordinate is hard to describe this region using Cartesian. It means using x and y. And one of the main reasons that we will use and you will use Cartesian polar coordinate is to describe what we call circular region. Every circular region, if you want to describe it, okay, you describe the polar coordinate of the point, not the Cartesian coordinate of this point. Okay, so that's really the main use in a way of the polar coordinate to describe those kind of regions. Okay. So if I want to describe, if I give you any simple region and I tell you describe this region using polar before we move on. So suppose I give you a region, very simple, nothing really hard. I give you the following region, something like that, this and this. And I can just plug in numbers. I can put 5 and 6, for example. Okay, that's a region. Describe this region using polar coordinate. How would you describe it? So you want to describe it to somebody. Tell them, okay, these are all the points whose polar coordinates satisfy those conditions. What condition the polar coordinates satisfy that will give you this region?
0 to
R
pi
is-
over 2.
What?
It would be 0 to pi over 2.
That's the theta,
Yeah, and then the r would just be 5 to 6.
and r will be 5 to 6. That's it. Very easy way to describe this region. The easiest possible way. Even than using Cartesian. It means either than using condition on x and y. So what do I mean by that? Let me make clear. If I want to use condition on x and y to describe this region, can anybody do it? Usually we use those because they are very easy. Can anybody think of what condition on x and y can we use to describe this region? Okay, I give you an idea. First, we have to describe that they are between 5 and 6. Okay, so one way we can say it, x squared plus y squared. If you have any point here, x squared plus y squared has to be between, not 5, it has to be between 25 and 36. Because a point here, the xy, if you have a point here, x squared plus y squared is 25, Pythagorean. If the point is here, x squared plus y squared is 36, Pythagorean. If it's in between, x squared plus y squared between here and here. But this would give me the whole ring. If I only want to get this piece here, I have to add the restriction x positive, y positive. So that will be in Cartesian. This region is always described in polar because that's really make more sense. Question before we move on. All right, now the last piece about sketching is the following. I'm going to talk about something called polar equation.
I have a quick question about the last one real quick.
Yeah.
How did you get the angle in Cartesian?
I cannot get angle. I just put condition on x and y. In Cartesian, there is no condition on, I couldn't put the condition on angle. It's hard. So what I said is in this particular problem, x positive and y positive.
Why can't you just say it's between 0 and 90?
Because in Cartesian, you have to give the condition on the x and the y.
Oh, I see. Okay.
That's the difference. That's why I insisted on writing it for you this way, so you know the difference.
Okay.
When you put that, when you describe the region in Cartesian, it means your condition has to be involving the x and the y only.
Okay, that makes sense. Yeah,
Yes.
thank you.
When I want in polar, it means the condition has to the condition to be on the r and theta. So regions will be described, and something you will definitely you will be working with in Calculus 3. Sometimes you have a region which is described in Cartesian, but you realize it's easier to describe it on polar, so you move from here to here, and you describe it from polar. And sometimes you may have to do the opposite. It's given in polar, you have to move to Cartesian. And usually you choose which description is easier to work with. Whenever the region is circular, like that, describing region in polar is way easier than in Cartesian coordinate. So now polar equation. What's a polar equation? Like so far, most of the equation we had is what we call Cartesian. So I gave you y equal x squared. So I gave you y in function of x. And when we said sketch this region, basically when you guys in middle school, wherever, then you took bunch of point, so x and y, you took bunch of point and you drew this region, which turns out to be a parabola. Okay, and this is a Cartesian equation because this is an equation that relates the x and y coordinate of every point on the curve. That's a Cartesian equation. Now, polar equation is an equation that relates the polar coordinate, r and theta. So polar equation is an equation of the form r is a function of theta. Okay, that's a polar equation. Cartesian equation is an equation of the form y a function of x, if you want. So this is the relation between x and y, Cartesian equation, and this is polar because this is a relation between r and theta. Now, sketching a polar equation is like sketching this region. If I tell you, sorry, sketching this function, if I tell you sketch this, you take the axis, you take the y, and you graph it. So sketching a polar equation means the following: sketch all point r theta. So no, sketch all point whose polar coordinate satisfy r is a function of theta. Okay, so let's sketch all the points where the polar coordinates satisfy r equal f of theta. Right? So that's what we're going to do. We're going to sketch some polar equation. So example number 1 is the following. Sketch the region r equal 1 plus cosine theta. It means we have to sketch all the point r theta, all the points such that the r is always 1 plus cosine. Okay, so the way we're going to do it, we're going to do it 2 ways. The first way is the most natural way. So here r is a function of theta. So what we're going to do is we're going to take a bunch of values of r, theta, because r is given as a function of theta. This is theta, and this is 1 plus cosine theta. Okay, that's the r. And I'm going to take a bunch of value of theta and find the r for each value of those and sketch. So right here, I'm going to do the sketching. Okay, let me say a word about this graph before we move on. There is 2 ways I can think of those 2 perpendicular lines. So one way I can think of them, this is the x and y, which is, of course, that's the x and y. Another way I can think, I'm going to remove x and y. I can think of this as something we call it the polar graph. Okay, the way I can think about it is like this. I can think of this line as the line where theta equal to 0. Okay. And I can think of this line as the line theta equal pi over 2. Does this make sense? Can I think of this line as the line theta equal to 0? Does it make sense? I stop.
Yeah, I think that makes sense.
Yeah, because if I take any point here, what's the theta?
0.
If I take a point here,
It's pi, but it's equivalent to 0. Still.
right, because the r is negative. So I can think of this as theta equal to 0. Can I think of this line as theta equal? It's the y-axis, but also I can think of it as theta equal pi over 2. Does it make sense? If I take a point here, the theta is pi over 2. If I take a point here, the theta is pi over 2, but the r is negative. So sometimes I can think of those axes as theta equal to 0, theta equal pi over 2, and this will be called a lot of times, sometimes polar plane. So it's like it's the xy plane, but my focus now is more on the polar coordinate than on the x and y. So now let us sketch. Okay. If theta is 0, what is my r? It means I plug in into the formula. It's 1 plus cosine of 0, which is equal to 2. So if theta is 0, it means I am on this line right here. That's why I'm emphasizing those. My r is 2. So this is the first point on my curve. So that's 2 and 0. And this is all my points are in polar coordinate. All the points are in polar. Otherwise, it will be confusing. Okay. Now, I'm going to take more values of theta. I'm going to draw the point. So suppose I'm taking theta is pi over 4. R would be 1 plus the cosine of pi over 4, which is 1 plus the square root of 2 over 2. That means if theta is pi over 4, theta is the angle. That's the theta. The r is 1 plus the square root of 2. So 1 plus square root of 2. Now square root of 2 is a bit less than 1, so it's somewhere in here. That's the r. This is the 1 plus the square root of 2 of 2. So that's the point right there on the curve. Okay, that's 1 point, and that's another point. So we're just going to take points and then connect them. Now, if theta is pi over 2, I have 1 plus cosine pi over 2. Now, cosine pi over 2 is a 0. I have a 1. So if theta is pi over 2, it means if I am on this line, that's why I'm trying to emphasize those lines, this is equal to 1. So this is the point right there. So this is the point 1 pi over 2. Remember, everything is in polar. That's the r, and that's the theta. Okay. Now I'm going to take more values, a little bit more values. So I'm going to, it's tedious to take all value. I'm going to take pi, for example. If theta is pi, what is r? 1 plus the cosine of pi. It means 1 minus 1 is equal to 0. So r is 0. R is 0, it means I'm back to the origin. So at pi over 2, when theta is pi over 2, it's here. When theta is pi, it is here. But the question is, what's happening in between? What is r doing in between? What do you think r is doing? Is it increasing? Is it decreasing? What's going on? Because I need to jump. I need to see what's happening when theta sweeps this region. What's happening to r?
R is decreasing the whole time.
Why is r decreasing? Is there any reason except that plug-in point?
I don't really know how to explain why it's, I mean, it's decreasing obviously like through the points you plug in, but
It's decreasing through the point to plug in. But now, well, let's see what's decreasing. And that's what's going to be my second approach to this problem. So that's my first approach, plotting point. The second approach, I'm not going to plot point. How is the cosine theta behave? The cosine theta is start here. At pi over 2, it's right here. Between pi over 2 and pi, that's what it does. Okay, that's at pi. So at pi over 2, that's the value of cosine, which is equal to 0. Between pi over 2 and pi, the cosine is negative. It's getting more and more negative. So the cosine is actually decreasing. That's going to cause the r to decrease itself. Okay, that's an approach that I'm going to take in a second. I'm going to do this problem in 2 ways. But for now, I'm going to take a value in between, 3 pi over 4, just to make sure. And this is 1 plus the cosine of 3 pi over 4, which is 1 minus the square root of 2 over 2. So I was at a 1. Now I'm taking 1. I'm taking away something from it. So we are somewhere here. Okay, and then this is going to go like that. And this here, it will do that. Okay. Now what's happening after that? I'm going to take at pi over 2, at 3 pi over 2. At 3 pi over 2, I have 1 plus cosine 3 pi over 2, which is 1. At 3 pi over 2, I am right here. Now I can take 5 pi over 4. By symmetry, the 5 pi over 4, it means when theta is 5 pi over 4 right here, I'm going again to have 1 minus square root of 2 over 2. The point would be here. So this is going to be right there. And finally, at 2 pi, let's see, I had to take a lot of points. At 2 pi, I am right there. This 1 plus cosine 2 pi, which is a 2. So at 2 pi, I am back to where I started with. Now in between, I can take 7 pi over 4 in between. At 7 pi over 4, so this is the theta. And this is going to be 1 plus the cosine of 7 pi over 4. Now, if we remember our trigonometry a little bit, that's the square root of 2 over 2, which is basically the point symmetric to that, right there. And that would be the graph. Okay, so remember in this picture, theta is the angle, r is the distance. This is the theta, and that's the distance. Now, do I stop at 2 pi or I keep going? Do I need to keep going?
You can stop.
Because why? Because the values of r will start repeating. Because it's 1 plus cosine theta. Okay, when I go after 2 pi, I'm going to start repeating myself, repeating myself, repeating myself, repeating myself, because the cosine theta start repeating itself after that. And then we can stop, and that's really the graph in polar coordinate. And as you can imagine, this graph is called cardioid because it looks like a heart. That's why it's called a cardioid. Okay, and that's really the graph. So every point on this graph, the polar coordinate of this point, the polar coordinate, satisfy the condition that the theta, the r, is 1 plus cosine theta. Means if this is theta, theta is always the angle. This from here to here is 1 plus the cosine, which is 1 plus square root of 2 over 2. Okay. Now I'm going to do this problem in a different way, kind of, because, you know, tabulating is tedious. So how can we do it without doing all those tabulation? So another way to do this problem is going to be a little bit confusing at the beginning, but then you will get hold of it fairly easily. All right, so another way to do this problem. The idea is I'm going to sketch two graphs. One of them shows me how is r changing with theta. So it means when theta increases, does r increases, does r decreases. So how r changes with theta. And the second graph would be what I'm going to call it the polar graph. It means when I'm going to sketch the curve. So let's see what I am talking about. So a second way to do this problem, as I said, listen to me, because at the first time will be hard, the second will be easy. So the second way to do this problem. I'm going to sketch two graphs, not only one. The first one is going to be, we're going to call it the Cartesian plane, the regular Cartesian plane. And here I'm going to sketch the graph of the function r equal 1 plus cosine theta in the following way. I'm going to imagine this is theta, and the y-axis is 1 plus cosine theta. It means in the first plane, in here, I'm going to sketch the graph of the following function, if you want. Y equal 1 plus cosine x, the graph of this function. Okay, because this will tell me if theta changes, how is r changes. Now, so right here, forget about polar coordinate, polar graph, and everything. I just want to sketch the graph of the function r equal 1 plus cosine theta. It means on the horizontal axis, the values of theta. On the vertical axis, the values of r. Now, how does the graph of 1 plus cosine theta looks like? Back to the Cartesian. The cosine itself, it starts at 1, it goes down, back up, and start repeating itself at 2 pi. 1 plus cosine, it takes the graph of cosine and shift it up by 1. So 1 plus cosine is going to look like that. This is going to be just the shift by 1. And then it's going to be this graph right there shifted. So it's going to be shifted. It's going to be a 2. And then it's going to go down, up, and then back up here. This is 2. And this is 2 pi. But here, the way I'm sketching this, the same way I sketch y equal 1 plus cosine x. Now, this is going to be my pi. I always like to draw the midline because it helps me. This point is going to be the pi over 2. And this point here is the 3 pi over 2. Okay, right now I'm not sketching the graph that I'm interested in. I'm only sketching the graph of r equal 1 plus cosine theta. It means in this graph, the value of theta are on the horizontal axis, and the values of r are the vertical value. So for example, if theta is pi over 2, this graph tells me that r is 1. If theta 3 pi over 2, this graph tells me that r is 1. If theta is 2 pi, this graph tells me that r is 2. If theta is pi over 4, this tells me, I don't know exactly, but it's this vertical distance from here to here. So this is the regular x and y axis. All right, now I'm going to do the following. Instead of plotting point like I did here for theta and for r, I'm going to use the graph to be able to move to the polar plane. So I'm going to move right here. So in here, this is, as I said, you can think of it as the x-axis or theta equal to 0. And right here, theta equal pi over 2. Okay. And then let us see how we are going to do it. That's my polar plane. That's where the actual graph will occur. All right. But I'm going to use this as a guideline instead of points as a guideline. All right. If theta is 0, r is 2. So if theta is 0, r is 2. That's my first point. Okay. If theta is pi over 2, so instead of plotting point, I'm going to read them off this graph. I will read them off this graph. If theta is pi over 2, r is 1. So if theta is pi over 2, it means I am right here. My r is 1. Now, look what the benefit of this graph. If theta is between 0 and pi over 2, instead of having to plot point to see what's happening, I'm going to read the behavior of r as a function of theta. If theta is between 0 and pi over 2, what is r doing? Remember, r here is this vertical distance. R is decreasing. So if theta sweeps this region, it means when theta moves from 0 to pi over 2, what's my r doing? According to here, my r is losing value. So that's how I'm going to interpret that. So instead of plotting point, I said, r is decreasing. So it's starting at 2, that's my r, and then the r means this is getting less and less and less. So this will give me the first piece of my graph. And this is sometimes I like that this region 1 is interpreted as this piece right there. So I'm not plotting point. I'm really actually trying to read how is r changing with theta and interpret. Now I keep moving. Between pi over 2 and pi, it means when theta is sweeping this region, pi over 2, all the way to pi. So I'm going to call this region 2. I don't have to, but just to make it easy. Okay, what's really going on here? At pi over 2, that's my r. At pi, my r is 0, because this is pi. But what's happening in between? Is r increasing or decreasing? And now there is no question that we can read this. What's r doing?
It's
Between pi
decreasing.
over 2 and pi, what's r doing? Just look at the graph now.
Decreasing.
It's actually decreasing. I don't have to pick point. That's actually how is r behaving. So the r, which is this distance right there, that's really my r. It's getting less and less. Now I am switching down. Okay. Now, between pi and 3 pi over 2. At 3 pi over 2, I don't need plot point. I'm just going to look at my graph. The r is 1, means that's the r. But what's happening between, so this is the region 2 if you want. That's the interpretation of the region 2. Now I'm going to interpret the region 3. Okay, between pi and 3 pi over 2. It means as theta sweeps this region, it means as theta go from here to here. So this is my theta, and it goes from pi to 3 pi over 2. What is r doing? It was 0. R is increasing. R is increasing. R is increasing. R is 1. So in this picture, as theta changes, what my r doing is getting larger and larger. Let's realize no points is needed. We're interpreting the behavior. Finally, so this is region 3 if you want. So I mean this piece 1 corresponds to that, 2 correspond to this, and 3 correspond to that. Now the final region. And of course we should see symmetry. I mean the graph, there's obvious symmetry in the graph. I mean, the values of r are symmetric. The values obtained between 3 pi over 2 to pi are the same that's obtained between 0 and pi over 2. Now the last piece, from here to here. I'm going to call this region 4. What is R doing? At 3 pi over 2, I am at 1. At 2 pi, I am at 2. What's happening in between? My R is actually increasing. So as theta sweeps this region, my R, which this is my R, is actually increasing. And this would be my graph. Okay, so that's the second approach to this way of graphing, which I find it actually better than the first. So we don't plot point, we basically graph. First, we do two graphs. The first one will tell me how is R changing with theta? How is R changing with theta? That's the first one. The second one, using those info, I sketch the real graph. Questions before I move on? Any questions? Okay, we're gonna do another one. Of course, the second one will be harder than the first. So now I'm gonna sketch the graph of the following. R equal, and I'm gonna use the second approach. I'm not gonna use the first approach. 1 minus 2 cosine theta, okay? So I'm gonna again draw two graphs. The first one, which helped me to figure out how is R changing with theta, and then I will use it to move here. So R equal 1 minus cosine theta. So here I am in the regular Cartesian coordinate. So that's theta, and that's the R. And I'm sketching, so for you in this case, it's like sketching y equal 1 minus 2 cosine x. That's the way I want you to think about it. So here I'm sketching 1 minus 2 cosine theta. All right, let's remember how does the graph looks like. You guys have any, how do you want me to sketch this graph? Anybody? If I tell you sketch the graph of y equal 1 minus cosine 2x, how would you do it without a calculator? Anybody?
I can't remember what the 2 does to the graph.
Anybody can help? It's stretch it by a factor of 2. So this first 2 will stretch it, sorry. So it takes the cosine and multiply each value by 2. The minus will do what to it? Come on, guys. You know that. The minus will deflect it across the x-axis. The 1 will shift it up by 1 unit. Okay, so how's the graph here? First, you start with the cosine. I mean, I'm doing it on this side a little bit. So that's the cosine up to 2 pi, but then it repeats. So that's the cosine. The 2, basically, it means it multiplies each value by 2. So if this is 1, this is multiplied by 2. If this is minus 1, this is multiplied by 2. The zeros are not touched, and this is multiplied by 2. So 2 cosine will take the cosine and stretch it by a factor of 2. Okay, that's the 2 cosine. Now the minus will do what to it? It flips it. So if this is 2, the minus will gonna basically flip it. So that's the minus 2. So the minus now, I'm gonna graph it like this. That's the minus. It just flipped the original one. That's the minus 2. What about 1 minus cosine? What does it do to the graph?
It just brings the whole graph up 1 point.
It brings the whole back up. So this midline right there is going to be shifted up by 1 unit up here. Everything else is going to be shifted. All right, so the cosine minus 2, basically the 2 stretch it, minus 2 is going to reflect it across the x-axis, and the 1 is going to shift it up. So now I'm going to see the right here, I need to sketch the end result. So the midline, this one, is going to be basically shifted by 1. And I usually like to draw this because it guides me. And then what's happening? Everything is being shifted. So there's going to be a 3 in here because the 2 will be shifted up. The -2 will be shifted up. So the -2 is going to be shifted to -1. And now I have the graph's going to look like this. Go down, up, back up, right there. And that's going to be the 2 point. Okay. And now let us pick up the important value. The important value is the value here, which is that's where the pi is in my original picture. And right there, this is the pi over 2 and the 3 pi over 2. But now those are shifted by 1 and shifted by 1. So my picture here, right there, is the pi over 2. And right here is the 3 pi over 2. End of my graph. Okay, so.
Professor,
Yes.
why is it not inverted anymore?
Because I did a very terrible mistake. Thank you very much. I like that. Okay. Okay. That's good waste of time from my part. So R equal 1 minus cosine 2 theta. Thank you very much. And okay, it's the same idea, but I forgot to invert it. It's going to affect the graph tremendously, of course. So I start with my midline as usual. This is the 1. That's everything is being shifted. And I'm going to start down here at -1. And I'm going to go up. And I'm going to go down. So it wasn't a lot of time wasting. So that's my 3 here. I'm peaking at pi. This is my pi over 2. And this is my 3 pi over 2. Okay. And this is the R. Right. I'm done with that graph. Usually it shouldn't take us too long, but now we just try to remember how the poor picture. Now I'm going to move this info all the way here. This info all the way here. So instead of plotting point, we're going to move this info. So right here I have, this is for me, all the point where the theta is 0. Right here, all the point where my theta is pi over 2, and so on and so forth. All right, so let us sketch the graph. And this one is a little bit hard, but once we get the hard piece, I'm done. All right, at theta equal to 0, watch very carefully what's going on here. When theta is 0, theta r is -1. It means if I plug in 0 here, r is -1. It means where is my point? My point is right there. Because this is the point, -1, 0. R is negative. Now, what's happening after that? R remains negative. What does this mean? If R is, I need those 2 points. Actually, those points are important for me. But let's see, I take a point here. If I take theta here, somewhere here, the R is negative. It means where is going to be the point that corresponds to this value of theta? In which quadrant?
Third quadrant?
It's going to be in the 3rd quadrant. It's going to be right. No. Yeah, it's going to be right here. Because if theta is here, this is my theta, my R is negative. It means my point is going to be right there in the 3rd quadrant. Now, I need this point. What's the value here? Anybody can figure it out. Tell me, how can I figure it out? What's the value here?
It's where theta equals 1/2, right? Or
Okay.
where the cosine of theta equals 1/2.
Right, so we're going to set R equal to 0. It means 1 minus 2 cosine theta equal to 0. Cosine theta is 1/2. It means what is the theta? Which angle has for cosine 1/2?
Pi over 3.
Pi over 3. Means this value here is pi over 3. So now what does this mean? If theta between 0 and pi over 3, I'm going to draw the line pi over 3 here. Theta equal pi over 3. It means if theta is between 0 and pi over 3, what's really going on? At 0, I am here. At pi over 3, my r is equal to 0. But what's happening in between? If I pick any theta, between 0 and pi over 3, my r is negative. It means my point is going to be down here. So at 0, I am here. If I pick any theta in between, my point is here. If I take this value of theta, my point is here. If I take this value of theta, my point is here. So the graph is actually going to be right there. That's going to be the graph. So I'm starting here. My theta is negative and it's getting less and less negative. Negative, it means my point is in this quadrant. Less and less negative, it means r is really approaching a 0. So that's between 0 and pi over 3. Now between 0 and pi over 2, my r is behaving very nicely. It's positive. And at pi over 2, I am at 1. So my r, as theta move from here to here now, my r is positive and it's going to do that. That's the piece. Now, between pi over 2 and pi, my r is also behaving very nicely. And at pi, it is at 3. At pi, it is at 3, behaving very, very nicely. Between pi and 3 pi over 2, r is still behaving nicely. It's positive and it's right there. It's between 3 pi over 2 and here where I'm, so that's 3 pi over 2. Now, this value here, if we do the math, right there by symmetry, that's 2 pi minus the pi over 3. So 2 pi minus the pi over 3. So this is, if I take, this is the line. So this is 2 pi minus pi over 3, which is 6 pi, which is going to give me 5 pi over 3. Between 3 pi over 2, 3 pi, it's still very nice. At 3 pi over 2, it is 0. Right here is where the mess starts again. Right here, my r is negative. My r is negative. So if, when theta is from 5 pi over 3 and 2 pi, my r is negative. It means my points are right there. And then the graph would continue like that. So I know I went very fast at the beginning. Tomorrow, there is no homework tomorrow because I'm going to work with you on those problems again tomorrow. The only homework I will assign for tomorrow are only the review problems. So there will be some kind of integration. But this, I will be working with you on it tomorrow till you have a better feeling for it. Okay? All right, sorry for so much time extra. Time, of course, is this. The class is dismissed. If you have any questions, you guys can stay.
Thank you.